Good morning, grade 11s. I hope you are doing well. It is time for our June exam, and I believe that you guys are ready for your paper 2. According to our paper 2 of June exam, we are told that they will bring grade 10 trigonometric functions. So today I just want us to look on what we must expect on our paper 2 regarding the grade 10 content. We are going to look at this question number 5 of 2018 November paper 2 grade 10. It's given as, they say, consider the function f at x is equals to minus 3 tan x. So the first part, they say we must sketch this function on the provided answer book. So in the exam, they will provide you with a provided answer book where you are going to draw. But now the graph is drawn between 0 to 360, meaning on the positive side of the Cartesian plane. So let's see how can we draw this graph. Let's quickly get a space here where we can draw the graph. To sketch the graph, you're gonna draw your Cartesian plane. You're gonna draw your Cartesian plane and then be able to sketch the graph on the Cartesian plane. Let me draw my Cartesian plane here. This is my Cartesian plane, and remember they said from 0 to 360. So we've got our 0 here. Let's have our 90 here, our 180 degrees, our 270, and then our 360. Now the graph is given as f at x is equals to minus 3 tan of x. So it's a tan graph. What do we know about a tan graph? We know that tan has got an asymptote at 90 degrees. There's an asymptote at 90 degrees. And there's another asymptote at 270 degrees. So now we have indicated the asymptotes. Another thing that we must consider on the graph, this is a negative function. As you can see there, our 3 is negative. Now, if you go back to the original graph of tan, which is positive, for example, f at x, it's equals to tan x. This is a kind of a graph that will be drawn in this form. When it comes from the 0 here, it's a graph that will actually go up and also come from this direction, passing 180 to this direction, and then ends here. This is the graph, the original graph of tan. But now the change is the graph is negative. So if the graph is negative, then it means now we are not going to draw this one, but the graph will start here. It will go down first. When it goes down, sorry, let me just put this correctly, close to the asymptote. So it will go down like this, and then since it went down, then it will come from this direction again, pass 180, and then close to the asymptote, and then it ended up, then it has to come from the top going to 360. And this is the graph that we are looking for. The orange one is the graph that we are looking for. And that's how we can do it. Then let's look at the next question. The next question, they say, hence or otherwise write down the period of the graph. Now the period of the graph, remember we used to say the graph of tan, it's 180 degrees period. And now we are considering 360 degrees as our period. So the period is 360 degrees. Now B, it says the equation of H, if H is a reflection of F about the x-axis. So now they are reflecting this orange graph about the x-axis, meaning the x-axis is working now as a what? As a mirror. If it's working as a mirror, if you look this orange graph into a mirror, then it will give you the green one, right? It will give you the green one because this one will be acting as a mirror. If you can go and look yourself in a mirror, you'll see what I'm talking about. What you see on the bottom, then you'll see upwards there. And then they say they want the equation. So the equation of the reflection of f minus 3 tan x will then be h at x. Remember, it will be positive, no more negative, so it will be 3 tan of x, and that is the equation they are looking for the green graph. And that's how we can do this one. So expect something like this. It's not that difficult how to draw the graph of 10. Yeah, and then let's continue looking into the next question, because it is also about a graph that is 5.2. We are given a cos graph. Sketch below is the graph of g at x is equals to a cos b theta. A, remember, it indicates our amplitude. A, it indicates our amplitude. And B, if we can check B, it affects the period of the graph. So as we are looking into this one, we can see that the graph still pass on the original point, meaning the value of B in this case, it's 1, because there's no change. If there was a change, then the graph will not be passing on the same original points. So this one is still passing on the same original points. That means our B is equals to 1. The first question, it says write down the values of A and B. So we've written already the value of B, which is 1. What about the value of A? The value of A, it depends on the amplitude of the graph. So we need to check from this line, from the x-axis, the graph goes up how many units to the turning point, and also on the bottom you can see that the graph from this line, it goes 2 units up to the turning point, and also going down 2 units to the other turning point, the minimum turning point, of which this one is the maximum turning point. This one will then be the minimum turning point. Now, to find the A, we consider that the graph is turning at 2, because that's our amplitude from this line, the x-axis. The graph, it goes 2 units up to the turning point and then comes back. So A is 2. Another thing that we need to talk about if we consider the original graph, of course, the graph that maybe will be given as f at x cos x. Remember, your a in this case is 1. So the turning point will be 1. Let's just put 2 in this case just to emphasize the point that I'm trying to make. So the original graph will be a positive graph like this one. Meaning, remember, the original one will come from 1, but this one will then come from 2. So the original graph, which is positive, it comes this way. There's a turning point at 180. It will pass at 270 and then ends there. Then the question that you must ask yourself, why now the graph is not coming? It doesn't have a turning point like this one from here coming from the upside from the up, and now it comes from the bottom. Then you must ask yourself why. Then it tells you that this is a negative graph, as this one is positive and this one is negative. So the equation will then be, or maybe the value of a will then be a, it's equals to a negative 2. They said write down. So the value of a is negative 2 and the value of b is 1. I hope that is clear. Question number 5.2.2. Use the graph to determine the value or the values for x where g at x is greater than 0. Remember, we are dealing with this one. Let me just take off this one so that we concentrate on what is given here so that people don't make mistakes. Okay, so what is the meaning of g at x being greater than 0? It simply means where the graph of g is positive. Where is the graph of g positive? It depends on this x-axis. If the graph appears above the x-axis, that is when the graph is positive. And when the graph appears below the x-axis, then the graph is negative. Meaning, on this portion, the graph is g at x is less than 0. But in this portion here, g at x is greater than 0. So it happens between 90 degrees and 270. How do we write this in an equality form? You can say 90 degrees is less than or equals to x, and x is less than or equals to 270. And that is the answer where g at x is greater than 0. I hope it's clear, people. Let's continue to the next question. 5.2.3. Determine the range of h if h is the image of g, if g is shifted down 2 units. If they take this graph and shift it 2 units down, it means this point here will be on -4, right? And this point here will be exactly here at what? At 0. So the maximum turning point will be at 0 and the minimum turning point will be at -4. The maximum will be at 0 and the minimum will be at -4. So we consider this 2 to write down what? The range, which will be now y is the element of -4 and 0. That will be our range for the new graph, the maximum turning point and the minimum turning point. The last one, 5.2.4, determine using the graph the value of. So you check what is cos 0, where is cos is 0, what is the value for x, For y, I mean